Hi everyone. Today we are going to discuss A-Levels Paper 1, Pure Maths 1, October-November 2019, Variant 2. So let's start. The first question is, the coefficient of x square in the expansion of 4 plus ax into 1 plus x over 2 whole power 6 is 3. Find the value of the constant a. So for this we need to open the second part of the expression by the binomial expansion, which is 1 plus x over 2 6, which will be equal to, I hope everyone knows the formula of binomial expansion. So this will become 1 power 6 plus 6c1 1 power 5 x by 2 power 1. The second term is x by 2 plus 6c2 1 power 4 x by 2 whole square. So this formula continues, but will not go further because we need just the first three terms, because we have to find out the coefficient of x square only, so we will not go further. So this will become 1, 6c1 is 6 into 1 raised to power 5 is 1 into x over 2 plus 6c2 is 15. You can calculate 6c2 or 6c3 by the calculator easily. So 6c2 will be 15 into 1 into x square over 4. So after simplification I will get 1 plus, this is 3 times 3x plus 15 over 4 x square. Now I'm going to write the actual expression now. This is 4 plus ax into 1 plus x over 2 6. So I just need the first three terms of this expansion, so I'll write these three terms. Actually I just need the second and the third term actually, because if I look this part clearly, so I have to find out the x square coefficient, so I need all the x square terms in this expansion. So if you look closely, you need just second and third expression term of this expression. Why? Because when this 3x will multiply with ax, it will become a term of x square, and when this 15 over 4x square will multiply with 4, it will become a term of x square. So we will not use any extra term. So multiply 4 into 3x, that is 12x, 4 into 15 over 4x square plus ax into 3x plus ax into 15 over 4 x square. So after simplification it will become 12x plus 15 x square plus 3ax square plus 15a over 4x cube. So if you look closely, we don't need this x term or this x cube term. We just need x square. So we'll discuss only these two terms, the second and third one. 15x square plus 3ax square. So take x square common, it will become 15 plus 3a. So if you look closely, the coefficient of x square in this expansion is coefficient of x square is 15 plus 3a, but it is given that the coefficient of x square in this whole expansion is 3. So we'll put 3 in place of this. This will become 3 is equal to 15 plus 3a. So take 15 on the other side. 3 minus 15 is equal to 3a. 3a is equal to minus 12. Therefore, a is equal to minus 12 over 3, which is minus 4. This is our answer. Okay ji, let's move on to the question number 2. This question is saying the point M is the midpoint of the line joining this and this. Find the equation of the line through M which is parallel to this equation. Okay, first of all we'll find out the midpoint. I hope all of you knows the formula for the midpoint, which is M x1 plus x2 over 2 y1 plus y2 over 2. So this is your x1 y1, this is your x2 y2. So by putting these values here, we'll get M 3 minus 1 over 2, 7 plus 1 over 2. So it will become 2 over 2, 8 over 2, and that is 1, 4. So this is the midpoint of the 2 points. Now he says that the line, find the equation of the line through M which is parallel to this equation. So we need the gradient of the line, required line. So the parallel lines have the same gradient. If we'll find the gradient of this line, actually this will be the gradient of the required line as well. So we need to find the gradient from this equation. Okay ji, the equation is x over 3 plus y over 2 is equal to 1. So convert this equation in y-intercept form by converting in y-intercept form. I hope everyone knows what is y-intercept form, which is y is equal to mx plus c. So this m is your gradient, which will be the coefficient of x. So we'll convert this whole equation in this form. So this will become y over 2 is equal to, take x term on the other side, minus x over 3 plus 1. So take 2 to the other side as well, because we need only y on the left side. So y is equal to, this will become minus 2 by 3x plus 2. So if you see, the coefficient of x is minus 2 by 3, therefore gradient of the required line will be minus 2 by 3, because the gradient of this line, so the gradient of the required line is also minus 2 by 3, because the both lines are parallel. Now we have the point, midpoint, and the gradient. We can use the gradient point form. Therefore, equation of line is, you know the gradient point form, y minus y1 m x minus x1. So x1 y1 will be the point 1 4, and this m is the gradient minus 2 by 3. Therefore this will become y minus 4 is equal to minus 2 by 3 x minus 1. So after simplification, take 3 on this side. This will become 3y minus 12 minus 2x plus 2. So take 2x on the left side and 12 on the right side. It will become 2x plus 3y is equal to 12 plus 2. So 2x plus 3y equals 14. This is the required equation of line. Okay, this is your question number 2. Now, question 3. Question 3 is, a curve is such that dy by dx is k over under root x, where k is a constant. The point this and this lie on the curve. Find the equation of the curve. Okay. So we have dy by dx equals k over under root x, which can also be written as dy by dx equals k x whole power minus 1 by 2, because we will take x on the upper side. So it will become minus 1 by 2, power minus 1 by 2. So it can be written as dy is equal to k x minus 1 by 2 dx. Now we integrate it so that we can get the equation of curve. So I'm going to integrate it. This will be k x minus 1 by 2 dx. Now k is constant, so it will come outside the integration sign, and this will become x minus 1 by 2 dx. Okay, let me check if I have an extra space for this question. No, I have to use this space. So students, please keep in mind the usage of your space is the key in the solution of the paper, because if you use the space carefully or sensibly, then you will face less issues, less problems during the solution of the paper. Okay, so if I'll integrate it, it will become k x minus 1 by 2 plus 1 over minus 1 by 2 plus 1 plus c. C is the constant. So after simplification, it will become y is equal to k x 1 by 2 over 1 by 2. Therefore y is equal to 2k x 1 by 2 plus c. Okay, now I'll put this point p1 minus 1 here, so I can get the value of k and c after getting two equations. I'll have to put these 2 points. So by putting p1 minus 1, so it will become so it will be minus 1 is equal to 2k 1 of 1 by 2 plus c. It will become minus 1 is equal to 2k plus c, or 2k plus c is equal to minus 1. This is our equation 1. Now I'll put the second point. So I'll make a line here so that I can use the next half of the part. So by putting q44, so this line will becomes 4 is equal to 2k 4 power 1 by 2 plus c. So this becomes 4 is equal to 2k, 4 power 1 by 2 is 4 plus c. So 4 is equal to 4k plus c, or 4k plus c is equal to 4. This is equation number 2. So I got two equations. I'll solve them by simultaneously. So I'm going to write the second equation 1 at the bottom of this equation. It will become 2k plus c is equal to minus 1. So I'll change the signs because I'm going to subtract them. So this will be cancelled. It will become 4k minus 2k, that is 2k is equal to 5, or k is equal to 5 by 2. This is our value of k. This is your first answer. Okay. I'll put this k here as well for the final equation. So by putting k in the first equation, 4 into 5 over 2 plus c, I will get c. So this 2 times 10 plus c is equal to 4, or c is equal to 4 minus 10, that is minus 6. So c is minus 6. This is my second value. So now I'm going to put k and c in this main equation, which is this one. So I will get the final curve. Therefore, the equation of curve will be y is equal to 2 into k's value is 5 over 2 x 1 over 2 plus c's value is minus 6. So this 2 will be cancelled with this one. So the final equation will be 5 under root x minus 6. This is the final answer. Okay, ji. Now the question 4. The question 4 is the diagram shows a circle with center O and radius R. Point A and B lie on the circle, and the angle AOB is 2 theta radians. The tangent to the circle at A and B meets at T. Express the perimeter of the shaded region in terms of R and theta. So first of all, we should know what to find. The perimeter of the shaded region includes the length AT, the length BT, and the curve AB. So we need to find all these lengths one by one, and then we'll add them at the end. Okay. So I hope I have this. Yes, I have this space only. So I'll have to make sure that my question is fixed in this space properly. I'll also suggest you people as well, before the start of the question solution, you should check how much space you have, so that you can readjust your solution, so you're working so that it should fit in the proper space. Now from triangle OAT, for example, I am going to, if I make a line here, I'll get a right angle triangle OAT. So from triangle OAT, I need to find AT, which is base, the perpendicular. The base is R, so the ratio between the base and perpendicular is tan. It is denoted by tan theta. So tan theta is perpendicular over base, which is AT over R. Our base is OA, which is R. So AT will be R tan theta. Therefore, BT will also be R tan theta, because the tangent from an external point to a circle are always equal in length. So these two tangents are same. If this is R tan theta, this is also R tan theta. So I got two lengths. Now I need the curve AB. For this, for curve AB, I will use the formula S is equal to R theta. So S is equal to R. So don't get confused with theta, because here your theta is 2 theta actually. So you have to put 2 theta here, because this theta is representing angle only. So their angle is now 2 theta. That's why you will put 2 theta instead of theta here. So S will be 2R theta. So I got all three lengths. Therefore, the perimeter of shaded region is AT plus BT plus AB curve, the sum of all the lengths. So this will become AT is R tan theta, BT is R tan theta, and AB is 2R theta. So it will become 2R tan theta by adding them plus 2R theta. This is the perimeter of the shaded region. This is our answer. Now, the part second is, in case R is 5 and theta is 1.2, find the area of the shaded region. I need to find the area of the shaded region. So first of all, you must know what to do. Actually, first of all, we will find the area of the kite, and then we'll subtract this white sector from the area of the kite, and we'll get this area of the shaded region. So first I need to find area of the kite. How can I find the area of the kite? If you see, I have divided this whole kite into two equal right angle triangles. So I'll find the area of triangle OAT, and then I'll multiply it by 2. So I'll find the area of the kite. Now we have R is equal to 5 and theta is 1.2 radian. So don't forget to switch your calculator to radian mode, otherwise your question will be wrong, because most of the time students forgot to switch the calculator to the radian mode, and they solve the question in degree mode. So definitely their question will be wrong. So area of triangle OAT, this is a right angle triangle. So we'll find the formula. we'll use the formula area is equal to 1 by 2 into base into height. It will become 1 by 2, base is 5 because r is 5, and height is r tan theta. If you see the previous part, you will come to know. So r is 5, tan theta is 1.2 radians. So after solving this by calculator, we'll get 32.15 centimeter square. This is the area of a triangle. So for the area of kite, I need to multiply it by 2. The kite's name is OATB. So is equal to 2 into 32.15, which is 64.3 centimeters square. So sorry, go beyond the line. You people shouldn't cross this boundary. You have to keep yourself confined in this working area only where the lines are. Now area of sector OAB, it is 1 over 2 r square theta. So it will become 1 over 2, r is 5, it is 5 square, and theta is 1.2. So now our theta is 2 theta, so it will be 2.4, because theta is equal to 2 theta here. If you want to see, I can show you again this one. So this sector, theta means the angle of the sector, which is actually 2 theta. So I need this sector. It will become 30 centimeter square, area of sector. Now the shaded area of shaded region, area of shaded region is equal to area of kite OATB minus area of sector. So it will become, this is your area of kite, 64.3 minus, this is area of sector, 30, which becomes 34.3 centimeters square. So this is our final answer. So always put a rectangle over your answer, so it should be highlighted. This was question number 4. Now question number 5. Diagram shows a solid cone which has a slant height of 15. This is our slant height, and a vertical height of h. This is our vertical height. Show that the volume V of the cone is given by this V1 over 3 pi 225 h minus h cube. The volume of the cone, this is the formula of the volume of the cone. So if we know the volume of cone is 1 over 3 pi r square h. If you see one thing, we didn't see any r in the answer. So it is clear that we need r in terms of h. So first of all, we'll find r, then we'll put r and h in this formula, we'll get the answer. So how can we find r? If you make a line here, so you will get a right angle triangle. This is h, this is r. So by Pythagoras theorem, 15 square is equal to r square plus h square. So take h on the other side. So it will become r square is equal to 15 square minus h square. So I'll put this r square in this formula. Therefore, volume of cone is equal to 1 over 3 pi. I'll put value of r square. It will be 15 square minus h square into this h. So 1 over 3 pi, 15 square is 2 to 5 minus h square into h. So multiply h by h inside, it will become 1 over 3 pi 2 to 5 h minus h square. So it is proved. This is our answer. Now part 2. Given that h can vary, find the value of h for which v has a stationary value. Determine, showing all necessary working, the nature of the stationary value. So from the previous part, we have v is 1 over 3 pi 2 to 5 h minus h cube. This is our v from the part 1. So we need to find dv by dh. That will be 1 over 3 pi 2 to 5 minus 3h square. So for the stationary value, this dv by dh must be equal to 0 because this is the gradient of this function, and for the stationary value, the gradient of that or at that stationary point should be parallel to the x-axis. Means gradient should be, the tangent should be parallel to the x-axis, so the gradient should be equal to 0. So for this stationary value, we need dv by dh is equal to, need to put dv by dh is equal to 0. So it will become 1 over 3 pi 2 to 5 minus 3h square is equal to 0. So these constants cannot be 0, therefore 2 to 5 minus 3h square is equal to 0, or 3h square is equal to 2 to 5. H square is 2 to 5 over 3, or h square is 75, which is h is 5 under root 3, or h is 8.66 centimeters. This is the value of h. Now determine, showing all necessary working, the nature of the stationary value, either it is maximum or minimum. And for this I need dv square, d2v over dh square, and d2v over dh square. For the nature, we need double derivative, always keep in mind. So it will become 1 over 3 pi minus 6h if you take the double derivative of this. So this will become 2, and it is minus 3, this is 3 2 times, so minus 2 pi h. So d2va over dh square is less than 0. So if you put value of h, minus 2 pi 8.66, which is minus 81.6, which is less than 0. So our d2v over dh square is less than 0. It means our point, stationary point, is maxima. Okay. This is our answer, nature of the point. Now Question number 6. The question 6 is given that x is greater than 0, find the two smallest value of x in radians for which this 3 tan into 2x plus 1 is equal to 0. Show all your necessary working. Okay, so 3 tan 2x plus 1 is equal to 1. Now take 3 on the other side. Tan 2x plus 1 is equal to 1 over 3. Or take tan on the other side as well. So 2x plus 1 is equal to tan inverse 1 over 3. Which is 2x plus 1 is 0.322. It is actually our alpha. So if you draw the 4 quadrants, first, second, third, fourth, and we know in first quadrant all is positive, in the second sine is positive, in the third tan is positive, and in the fourth cos is positive. So now you can see the tan is positive. It means our angle can be in first or third quadrant. So this is 0.322, this is 0.322. These are our alphas. So the theta is equal to alpha in the first quadrant always, and for the second angle the theta will be this one, which is pi plus alpha. So the first is alpha is equal to theta. Theta is equal to or alpha is equal to theta means 2x plus 1 is 0.322, or 2x plus 1 is pi plus 0.322 for the third quadrant. So this will become 2x is equal to minus 1 plus 0.322, or 2x is equal to minus 0.678. As if you can see the start of the question, that x is greater than 0. Here the x is less than 0, so we'll ignore this value. So for the second angle we have to go again one complete rotation, and it will become 2 pi plus 0.322. So the first now our one angle will be pi plus alpha, and the second angle will be the 2 pi plus, because this angle is ignored, it became negative. So it will become 2x plus 1 is equal to 2 pi plus 0.322. Now if you solve this one, it will be 2x plus 1, pi is 3.142 plus 0.322. So 2x plus 1 is equal to 3.464. So take 1 on the other side. So 2x is equal to 3.464 minus 1, or 2x is equal to 2.464, or x is equal to 2.464 over 2, which is 1.232. This is first value of x. And the second is this one. 2x plus 1 is 2 into 3.142 plus 0.322, and this will be 6.284 plus 0.322. This will be 6.605, 2x plus 1. So 2x is 6.605 minus 1. 2x is equal to 5.605, or x is equal to 5.605 over 2, which is 2.803. This is our second answer. Okay, this was part A. Now, okay, part B is the function this f 3x square minus 2 sine square x is defined. For this, express fx in the form a cos square x plus b, where a and b are constant. If you see closely that we cannot see sine square in the answer, it means we need to convert the sine square into cos square. I hope you know how to convert. Fx is 3 cos square x minus 2 sine square x. We know that sine square x is always 1 minus cos square x from the identity, trigonometric identity. So we'll put that value here. It will become 3 cos square x minus 2 into 1 minus cos square x. So this will be 3 cos square x minus 2 plus 2 cos square x. So it will become 5 cos square x minus 2. So we can also write it as 5 cos square x plus into minus 2. Therefore, the a is the coefficient of a cos square, which is 5, and b is constant, which is minus 2. These are the two values, our answer values. Okay, now part 2. Find the range of f. For the range, we have domain 0 till pi. So we can put three values, 0, pi by 2 and pi, and we can find out the extreme values. When x is equal to 0, your fx, which is 5 cos square 0 plus into minus 2, and you know cos 0 is 1, so 5 minus 2, which is 3. This is our first value. When x is pi by 2, our fx will be 5 cos square pi by 2 plus into minus 2. So cos 90 is always 0. So this whole will be 0 minus 2, which is minus 2. And when x is equal to pi, fx will be 5 cos square pi plus minus 2. This is again 1 minus 1. So cos pi is minus 1. So minus 1 square is 1. That's why 5 minus 2, which is 3. Therefore, the range will be between 3 and minus 2. This is the range of the function. Now, question number 7. Question number 7, I will not uh, read the whole question. It's too lengthy. I'll just straight away start the answer to save my time. So I hope you, when you read all the question, the whole question, you will get to know the important information of the question. Express each of the vector PB and PQ in terms of I, J and K. So first of all, PB. So for PB, you are here and you are going to B. So it means first of all you will come from P to O, then O to A, then A to B. This will be your route. So it will be PO plus OA plus AB. So since we have OD, OD is 2I plus 10K. So OP is actually OD over 2. This one from the figure we can see P is the midpoint. So this will be 2I plus 10K over 2, which will be I plus 5K OP. But I need PO. It means PO is minus I minus 5K because we are going against the direction. So we'll put minus I minus 5K instead of PO. We have the value of OA, which is 6I, and we have the value of AB, which is equal to OC. So AB is equal to OC. So we can write OC instead of AB, and the value of OC is 8J in the question. So after simplification, I will get answer 5I plus 8J minus 5K. This is PB. Okay, this is our first answer. Now PQ. PQ is, we are here and we have to go to Q. So for this we'll use the root PD plus DG plus GQ. So PD plus DG plus GQ. So PD is half of OD. So I can write OD over 2 instead of PD. DG is parallel to OC, so DG and OC are equal, so I'll write OC instead of DG because I have the value of OC, I have the value of OD as well, and GQ is the half of GF, which is OA, so I can write it as OA over 2. So OD is 2I plus 10K over 2 plus OC is 8J and plus OA is 6I over 2. So this will be I plus 5K plus 8J plus 3I. So after simplification, it will become 4I plus 8J plus 5K. This is our PQ. This is second answer. Okay. Now, the second part is determine whether P is near to Q or to B. So for this, we need to find the distance of P from Q and the distance of P from B. So for this purpose, I need both distances. First of all, distance of PQ, which is the magnitude of PQ vector. And from the previous part we'll find the magnitude, which is 5 square. I hope you all know how to find the magnitude, plus 8 square plus minus 5 square, which is 114 under root, that is 10.7. And now PB is the magnitude of the vector PB, which is 4 square plus 8 square plus 5 square. So this will be 105 square root, which is 10.2. So PB is less than PQ, because 10.2 is less than. It means P is near to Q. PQ yes. 1 second, I have to calculate. Yeah, sorry, this is PB. This is PB and this is PQ. So PB is less than PQ, therefore P is nearer to Q. P is more near to Q than B. This is part 2. Part 3 is use a scalar product to find the angle BPQ. Okay. The formula for the scalar product is PB dot PQ is equal to PB PQ cos theta. Therefore, cos theta will be PB PQ vectors product over PB determinant magnitude PQ magnitude. So this will become cos theta, PB is 5i plus 8j minus 5k, and PQ is 4i plus 8j plus 5k over the magnitudes, which are 5 square plus 8 square plus minus 5 square into magnitude of PQ, which is 4 square plus 8 square plus 5 square. So it will become, the product of two vectors is the coefficients of I will be multiplied with each other, then the coefficients of j, then the coefficients of k. So it will be 5 into 4 plus 8 into 8 plus minus 5 into 5 over under root 114 into under root 105. So this will be 20 plus 64 minus 25 over 109.41 cos theta. So cos theta will be finally 59 over 109.41. This will become theta is equal to cos inverse 59 over 109.41, which is 57.366, which can be equal to 57.43 significant figure answer. This is our answer. Okay, the next question 8 is over a 21-day period. It means the n is 21. An athlete prepares for a marathon by increasing the distance she runs each day by 1.2 kilometers. It means D is 1.2 kilometers. Okay. On the first day she runs 13 kilometers. It means A is 13. This is the data we got. Find the distance she runs on the last day, 21-day period. Means we need to find the 21st term. So, the formula is Tn is equal to A plus n minus 1D. So, this is T21 is equal to 13 plus 21 minus 1 into 1.2, which is 13 plus 20 into 1.2, which is 13 plus 24, and that is 37 kilometers. So the last day she will run 37 kilometers. This is the answer. Now, find the total distance she runs in the 21-day period. So we need the sum of all 21 days. So the formula for sum is Sn is equal to n over 2 A plus L. So there is another formula, so I'll use this one, is more convenient. Other one I can also write here. Sn is n over 2 into 2a plus n minus 1d. So I already got the last term, so I'll use this one, which is more easier to use in this case. So this is 21 over 2, n is 21, a is 13 plus the last term is 37. So this will be 10.5 into 50, that is 525 kilometers. This is the total distance she will run in 21 days period. Okay. The next question is find the first. This is the question from geometric progression. The last part was arithmetic progression. So I hope everyone knows the formula for the geometric progressions. The first, second and the third term is this x, x minus 3 and x minus 5. So we know the first term is always a, which is first term, which is x, and the second term is always ar, which is x minus 3, and the third term is ar square, which is x minus 5. So these are the first three terms of geometric progression. Now we know the r, which is called common ratio, is the ratio of second to first term or third to second term. So the ratio of second to first term is ar over r, x minus 3 over x, or the ratio of third to second is ar square over ar is equal to x minus 5 over x minus 3. So this will become ar over a. So this will be AR will not cut. So R is x minus 3 over x, and R will be cancelled this, A with this, and R is x minus 5 over x minus 3. Since both are equal, so the right sides will also be equal. It will become x minus 3 over x is equal to x minus 5 over x minus 3. So by cross multiplying, I will get x into x minus 5, x minus 3 into x minus 3. So this will become x square minus 5x is equal to x square minus 6x plus 9. So this x square will cancel with this one, and I will get minus 6x minus 5x is equal to 9, or x is equal to 9. This is my value of x. Now find the fourth term of the progression. The fourth term is AR cube. So I need A and R values. I have A is x, so A is x is 9. So this value is already I have. So what is R? I can use any one of these. R is x minus 3 over 3. So put the value of x here, 9 minus 3 over 3, which is 6 over 3, that is 2. So I will put all these two values here. So it will become 9 into 2 cube, which is 1 second. So this is 9, sorry, this is 9, x minus 3 over x. So this is 9. So 6 by 9, that is 2 by 3. So 2 by 3 whole cube. It will become 9 into 8 over 27. 9 ones are, 9 threes are 27. So 8 over 3 is our fourth term answer. Now find the sum to infinity of the progression. So we know the formula for the sum is A over 1 minus R, 9 over 1 minus 2 by 3, which is 9 over 3 minus 2 by 3, that is from the LCM. It will become 9 multiplied 3 over 1, which is 27. This is the sum. That is the question number 8. 9. So the question 9 is, okay, question number 9 is we have two functions fx and gx, where k is a constant. Find the value of k for which the line y is equal to gx is tangent to the curve y is equal to fx. Okay, we have y is equal to gx, which is 2x minus k, and we have y is equal to fx, which is y is equal to 2x square plus 8x plus 1. So put the value of y from here in the second equation. We'll get 2x minus k is equal to 2x square plus 8x plus 1. So take all the left hand side terms on the right hand side. It will become 0 is equal to 2x square plus 8x plus 1 minus 2x plus k. So the final term will be 2x square plus 8x minus 2x, 6x plus 1 plus k is equal to 0. So a is 2, b is 6, c is 1 plus k. Since these the one line is tangent to the other, so there should be one answer, one root only. It means the discriminant b square minus 4ac should be equal to 0 for single root. I hope you know this condition. So put the values here. 6 square minus 4 into 2 into 1 plus k is equal to 0. 36 minus 8 into 1 plus k is equal to 0. So from here 36 minus 8k is equal to 0. 36 minus 8 is equal to 8k, or 28 is equal to 8k, or k is equal to 28 over 8, which is 3.5. This is the value of k. Now, in case where k is minus 9, find the set of values of x for which fx is less than gx. So don't forget to put the value of k minus 9 here. So fx is less than gx. It means 2x square plus 8x plus 1 is less than 2x plus 9, because there is 2x minus k. So if you put k is equal to minus 9, it will become plus 9. So we'll solve this inequality. 2x square plus 8x plus 1 minus 2x minus 9 is less than 0. Will become 2x square plus 6x minus 8 is less than 0. So for critical values, I will solve this equation for critical values. It will be 2x square plus 6x minus 8 is equal to 0 for the moment. So after solving, I will not solve. You know how to solve the quadratic equation. The critical values will be 2x minus 2 so it will be 2x minus 2 into x plus 4 is equal to 0. So the two values will be x is equal to 1 and x is equal to minus 4. So these are the critical values. If I plot these values on the grid, it will be like this. Minus 4, this is 1. So our parabola will be like this. So it is actually less than 0. It means area below the x-axis is our answer. So it is less than 1 but greater than minus 4. So our inequality will be less than 1 greater than minus 4. This is the answer. Okay. Part 3. In a case where k is minus 1, g inverse fx and solve, find g inverse fx and solve the equation g inverse fx is equal to 0. Okay. Gx is 2x minus k. Therefore, gx For k is equal to minus 1, gx is 2x plus 1. So let y is equal to 2x plus 1. So make x the subject, y minus 1 is equal to 2x, or x is equal to y minus 1 over 2. So I'll write g inverse x instead of x, and I'll replace all y's with x. So x minus 1 over 2. This is g inverse x. Now g inverse fx means g inverse fx means replace all x with fx. In this g inverse x, it will become fx minus 1 over 2. So what is fx? That is 2x square plus 8x plus 1. From the previous part, you can see minus 1 over 2. So this is 2x square plus 8x over 2 g inverse fx. So since g inverse fx is equal to 0 for the solution, so put g inverse fx is equal to 0. So it will become 2x square plus 8x over 2 is equal to 0. Take 2 common. X square plus 4x over 2 is equal to 0. This is cancelled. So this is x square plus 4x is equal to 0. X common, x plus 4 is equal to 0. So x is equal to 4, x is equal to minus 4. X equal to 0 and x equal to, these are the two values. Answer. Okay. Now express fx, next part, express fx in the form this, wherein we are going to demonstrate the least value. Okay, we know fx is equal to 2x square plus 8x plus 1. So I'm going to convert it in this form, and it is called completing square form. So I hope everyone knows how to convert. So 2x square plus 8x, I will separate this part from the other part. I will make this as a whole square, complete square. First of all, I will take 2 common. It will become 2x square, x square plus 4x plus 1, and 2x square plus 4x, I will add the square of the half of the coefficient of x. The coefficient of x is 4, its half is 2, so 2 square. I will add and subtract 2 square to make it a complete square. This is the procedure. So 2, this will become, this part will become x plus 2 whole square minus this 2 square is 4 and this is 1. So multiply by 2 inside. So this will become 2 into x plus 2 whole square minus 8 plus 1, and 2 into x plus 2 whole square minus 7, or I can write it as fx is equal to 2 into x plus 2 whole square plus into minus 7. So if you see, I have converted this fx in this form. So the least value will be this one. Therefore, least value is minus 7. This is answer. Okay. Question 10, last question of this paper. Okay, question number 10. The diagram shows a part of the curve y is equal to 1 minus 4 over 2x plus 1 whole square. The curve intersects the x-axis at A, and the normal to the curve at A intersects the y-axis at B. Obtain expressions for dy by dx and integration of y dx. Okay, first of all, the dy by dx. We know y is 1 minus 4 over 2x plus 1 whole square. This is y. So I can write it as 1 minus 4 into 2x plus 1 power minus 2. So I'll differentiate it. Dy by dx. The differentiation of a constant term is 0. And the differentiation of this 4 and 2 minus 2 comes first. 2x plus 1 minus 2 minus 1 into the differentiation of inside term 2x plus 1, which is 2. So this will become this minus into minus plus. 4 2s are 8, 8 2s are 16 into 2x plus 1 minus 3. So dy by dx is 16 over, I will bring this term to the denominator to make 3 positive. 2x plus 1 power 3. This is answer. Now for the integration of y, this is y dx is equal to this one, 1 minus 4 2x plus 1 minus 2 dx. Okay, so this will become 1 dx minus 4 2x plus 1 power minus 2 dx. So 1 dx is x minus 4. I will integrate this. This is my 2x plus 1 minus 2 plus 1 over minus 2 plus 1 into the derivative of this inner term, which is 2. So this 2 will become, cancel this 4 by 2. It becomes x, this minus x 2 into 2x plus 1 minus 1 over minus 1. So this minus will make this minus plus. It become x plus 2 over, I will take this 2x plus 1 in the denominator, 2x plus 1 1 plus c. This is the y dx. So this is second answer. Now find the coordinates of B. For this we need to understand the diagram first. If you see this is normal to the curve. AB is normal to the curve, and this normal is intersecting y-axis at B. So first of all, I need to find out the equation of this normal. Then I will intersect this equation. I will solve this equation with the y-axis, and I'll get the coordinates of B. So first of all, I need to find the equation of normal of A, and before that I need the coordinates of A. So how can I find the coordinates of A? Because A is on x-axis. So on x-axis y is always 0. So I'll put y 0 in this curve, and I'll get the value of x. How? Just see. As A is on x-axis, therefore 1 minus 4 over 2x plus 1 whole power 2 is equal to 0, because y is always 0. Now it becomes 4 over 2x plus 1 whole square is equal to 1. By cross multiplying, it becomes 2x plus 1 whole square is equal to 4. By squaring both, taking square root of both sides, 2x plus 1 square is equal to 4, and it becomes 2x plus 1 is equal to 2. We'll take the positive value of 2 because if you remember, the a is on the right side of the x-axis, so we'll not take the negative value. So it becomes 2x is equal to 2 minus 1. X is 1 over 2. Therefore, a is 1 over 2 and 0. These are the coordinates of a. Now I need to find the normal to the curve, and for the normal I need the tangent to the curve. The tangent is dy by dx. Since y, I know y is equal to dy by dx, from the part 1, dy by dx is, I have already calculated it, so I'll use that value, 2x plus 1 power 3. So put x is equal to 1 over 2, because I need the gradient of the curve at point A. So I'll put x equal to 1 by 2 here. This will become 16 over 2 into 1 over 2 plus 1 whole cube, 16 over 1 plus 1 whole cube, 16 over 2 cube, 16 over 8, which is 2. It means the gradient of the curve at A is 2. Therefore, the gradient of normal at A will be m is minus 1 over 2, because you know the gradient of two perpendicular lines, the product of gradient of two perpendicular lines is always minus 1. So m1 into m2 is minus 1. So this m1 is the gradient of the tangent, this m2 is the gradient of the normal, it's minus 1. So take 2 on the other side, so m2 is minus 1 by 2. This is the way I find out the gradient of the normal. Now the normal is also passing from A, so I have A and I have this gradient, so I'll use point intercept form to find the equation of normal. Therefore, equation of normal, y minus y1, which is 0, m minus 1 over 2, x minus x1, which is 1 over 2. So by simplifying it, it will become y is equal to minus x over 2 plus 1 over 4. This is the equation of normal. So the normal is cutting y-axis at B, since normal intersecting y-axis at B. Therefore, I need some space for, therefore we'll put x is equal to 0, because on the y-axis all x-axis are 0. So I'll put x equal to 0 in the normal equation. So it will become come up to a little shortage of the space. So y is equal to 0 over 2 plus 1 over 4. So y is equal to 1 over 4. Therefore, coordinates of B are 0 and 1 over 4. This is our answer. The last part is showing all the necessary working, the area of the shaded region. So if you see the figure again, we need this area of the shaded region. So just understand how we'll go, how we'll solve this area. First of all, I will find out this area below the x-axis. This is my 1/2 boundary value, and this is my 0. So I got two boundary values. So the area under the curve below x-axis, then I will use find out the area above the x-axis, and then I'll add them. You can also go the other way. You can find out the area of the curve according to the y-axis as well. So I'll just use the x-axis approach. So for this reason, the formula is area below x-axis. This is area is equal to 0 1/2 y dx, because these are the two boundary values which I explained earlier. Y dx, this is a formula. So it will be 0 1/2 1 minus 4 over 2x plus 1 square dx. Okay, so so I can write it as 0 1/2 1 minus 4 into 2x plus 1 minus 2 dx. So now I'm going to integrate it. The integration of 1 is x, and the integration of this 4 2x plus 1 minus 2 plus 1 over minus 2 plus 1 into derivation of this inner function, which is 2. Now the boundaries will be like this. Now this 2 will be cancelled with this one. This is minus 1. It will become x minus minus plus 2 over 2x plus 1 0 1/2. Okay, I'm going to apply the boundaries 1/2. First I'll put 1/2 plus 2 over 2 multiply 1/2 plus 1 minus, then I'll put 0 minus 2 over 2 into 0 plus 1. So this becomes 1 over 2 plus 2 over 2 minus 0 minus 2 over 1. So this is 1. So 1 over 2 plus 1 minus 2, 1 over 2 minus 1, which is minus 1 over 2. So this is area below the, don't worry about this negative, because area can never be negative. This negative is showing that this area is below the x-axis. So actually our area is 1 over 2. So this is the area below the x-axis. Now below x-axis, area of triangle above x-axis. Area of triangle, because if you see the figure, this is a triangle, this one above x-axis. So I'll use the area of triangle formula. Area of triangle above x-axis is 1 by 2 into base into height, which is 1 by 2, base is 1 by 2 and height is 1 over 4, so which is 1 by 16. Therefore, total area, which is this area plus this area. So area below the x-axis is 1 over 2 plus area above the x-axis is 1 over 16, which becomes 9 over 16. So this is our final answer. So this was the paper 1-2 October-November 2019. So that's it for today. That's it. This is the end of the video. Please subscribe my channel for the next updated videos, and see you in the next video. Thank you very much.